There we go. I'll wait just another minute. It's only 6:59.
Okay.
Carrie, how are you doing in the course? How's it going for you?
You know, it's going so much better than I thought it was going to. I'm not the greatest at math, and so I was worried, but I really am enjoying the ALEX program. I feel like it helps me work at my own pace and not have to worry about coming up to the level of some of maybe the other students.
That's what I really like about it. I've been using it for probably, this is my 4th year. I'm the only one in our department that uses it, and I love it. And I get so much good feedback from students, and they say pretty much what you're saying.
Yes. It's been very nice to have it. And so I was really worried when I started because I was like, I'm pretty sure I need to be in remedial math class. It's my math skills are not great, but it's made it super easy. Um, and it's been very, very easy to use.
I'm so glad you said that. I love to continue to get good feedback about ALEX. So I try to talk about it with some of my colleagues, and there was one that was going to use it, but then COVID happened, and so she decided not to take that leap of faith yet. So, well, we better get started here. So let's get started, and feel free to jump in and ask any questions. So
Okay.
I'm just going to go over the written work required topics in order. So your first 7 questions on the test will be the written work required topics.
Okay.
So let's take a look at this topic first. Writing the equation of the line through 2 given points. And so what we need to do first is to identify the ordered pairs associated with our points, that is the X and Y coordinates. So I apologize if this graph isn't more, we can't see the grid lines as well as I would like, but we can still make do, I think. So if I want to get the X coordinate of this point, we just go straight down to the X axis, and looks like it is at -1. If we want to get the Y coordinate of this point, we go straight over to the Y axis, and it seems like it is at 2. Right here, if we want the X coordinate of this point right here, we go straight down to the X axis, looks like it's at 5. And then to get the Y coordinate, we go straight over to the Y axis, and it is 4. So that's how I got those ordered pairs.
Okay.
And let's take a look at what I did down here. I just copied these ordered. Well, first I labeled the ordered pairs. So I just designated this as the first point and labeled the X coordinate as X1, meaning it comes from the first point, and Y1 coming from the first point. And labeled this one as the second point. So the first coordinate is X2, and the second coordinate is Y2. And I just copy those down here. And what we want to do in order to find the equation of the line, no matter how we find the equation of our line, we definitely need the slope. Whether we use slope-intercept form, point slope form, we still need the slope. So the slope is the change in Y over the change in X. And let's just, I've got the slope formula written right down here. M for slope equals Y2 minus Y1 over X2 minus X1. So I labeled the coordinates up here. So Y2 is this 4 right here. So I put in 4 for Y2. And then minus Y1. Y1 is right here, 2. So we have 4 minus 2 in the numerator here, divided by x sub 2. So x sub 2 is 5. So I put that 5 in for x sub 2. So it ends up right here in the denominator. And then we have minus x sub 1 going back up here. We see that x sub 1 is negative 1. So I wrote down negative 1. So let's just first finish this calculation. 4 minus 2 is 2. 5 minus a negative 1 is 5 plus 1, which is 6. And then this reduces to 1/3. So you can either take your calculator, your graphing calculator, and put in 2 divided by 6 and math frac it. So on your calculator, to do math frac, which reduces fractions for you, you can go to the math key in the very first column. It's the 4th button down, and then do enter, enter. So whatever you put in, say I put in 2 divided by 6 on the home screen, and then I push that math button in the first column, 4th button down, and then hit the enter button twice. And that will change it into a fraction in reduced form, which gives me the 1/3. Or you can say, I'm going to take this 2 and divide it by 2 and get 1. And I'll take this 6 and divide it by 2 and get 3. So our slope is 1/3. For this problem, I prefer to use point slope form of the equation of a line instead of slope intercept form, because we know not only do we know what our slope is, but we also know what y1 and x1 are. We can go back up to our graph to see what y1 and x1 are. So I wrote down the point slope form of the equation of a line right here, and then we're just going to plug in. A line represents, on each line, we have points, and we have an infinite number of points, each which we can write the xy ordered pair for. So we need our answer to leave the x and y in our answer, because we really need to be able to have this work for each and every point on our line. In other words, the x and y coordinate of every single point on our line, that combination will satisfy this equation. So here's our point slope form, y minus y1. y1 for us is 2. y1 here is 2. So we put the 2 in for y1, equals the slope, which we just found up here. It's 1/3 times x minus, so x minus x1 is right here. It's -1. And now we just need to clean this up and solve for y. So this I'm just copying over. Let's just copy this over. X minus a minus is x plus 1. And let's go ahead and solve for y. The only thing we have to do on this side is to add 2 to both sides. So let's go ahead and add 2 to this side and 2 to this side. That will leave us with y on this side, because -2 plus 2 is 0, and y plus 0 is y. So over here we have y equals on this side now. We want to just copy 1/3 x on the other side over, and then plus 1/3 plus 2. You could go to your graphing calculator, put in 1 division sign 3 plus sign 2, and then math bracket by going to the math key in the first column and then hitting enter, enter. And I got a positive 7/3. Or you could convert this to and turn it into thirds. So I could multiply the top and bottom by 3 here and get 2 times 3, which is 6 over 3. And then plus 1 over 3 would be 7 over 3. Any questions on this problem so
No,
far?
that one actually was a lot much easier than the way I'd been doing it. So that's good.
Oh, that's good too. And let me tell you, I'm a fan of quick checks. So you can, both of these points need to satisfy this equation of a line. So what you could do is you could check them both, because quick checks are important, especially if you want all the points you can get on a test. So let me show you how that's done. I'll do one of them. If I want to check this point right here to make sure it satisfies the equation, that means x is -1 and y is 2. So in for x, I want to put -1 here. And in for y, I want to put 2. So let's see. So if I put -1 in here for x, I get 1/3 times a -1, which is -1/3, plus 7/3. -1/3 plus 7/3 is actually -1 plus 7, which is positive 6/3 if you do the calculation, and 6/3 reduces to 2. So I see that this first point here satisfies my equation. So I have a warm and fuzzy that I've got the correct equation. You could also check this one as well, if you wish. So I like the quick checks because not only can you get your bars quicker in ALEKS, but you can get a higher score on the test.
Yay.
Yeah. So any questions?
I don't think so.
Okay, good. We can always come back. So let's take a look at this next topic. I don't know what's going on with my throat. I've got bad allergies, but so I'm going to take a little sip of tea. Okay. So this one, word problem involving average rate of change. Average rate of change is slope. So this average rate of change up here, these key words right here, this is just slope. This is what we call M. So you definitely want to keep that in mind when we do this problem. Dale is cooking a roast. That sounds really good. The table below gives the temperature R of T of the roast in degrees Celsius at a few times T in minutes after he removed it from the oven. In part A, we are asked to find the average rate of change for the temperature from 0 to 15 minutes. So that 0 to 15 minutes is the time. So I'm going to look in this as a T table. Right here, it's got a T. Here's the down part of the T and the cross part of the T. This T table consists of a collection of ordered pairs. So we want to find the average rate of change for the temperature from 0 to 15 minutes. Here's 0, right here, 0 minutes. Here's 15 minutes. So I circled those in red because these are 2 ordered pairs that we are going to use to find this average rate of change. It's just the slope. And then down here, find the average rate of change for the temperature from 30 minutes to 75 minutes. So I'm looking down here, I see 30 minutes, so I circled this ordered pair in blue. And then down here, 75 minutes, I circled this ordered pair in blue because we're going to use the blue ordered pairs for part B. And you notice there's a 60 in between here, so that's why I had to circle them separately. We're not going to use that 60 in this problem. So let's do this first. Let's do part A. So first of all, I wrote down the ordered pairs. 0, 193.5 right here. Labeled the first one with X sub 1, Y sub 1. And then the second ordered pair we're using encircled in red is 15, 166.5. Copied that down and labeled it with X sub 2, Y sub 2, because this is the X coordinate of the second point, and this is the Y coordinate of the second point. Now, while we're at it, we might as well do this for part B. We want from 30 minutes, which is right here. So we want this ordered pair, 30, 130.5. 30, 130.5. And then this ordered pair encircled in blue, 75, 22.5. And we labeled this one with X1, Y1, this one with X2, Y2. And all we have to do from now on in this problem is actually just calculate the two slopes that we need. So in part A, I wrote down Y2 minus Y1 over X2 minus X1, which is just the formula for slope. Definitely need to know that for the test. So I'm just going to plug in. Y2 for part A is 166.5. Minus sign, Y1 from part A, 193.5. Divided by X2 from part A, X2 is 15, minus X1 is 0. We just need to do this calculation. Grab the calculator, especially for the numerator, 166.5 minus 193.5. And I get negative 27 in the numerator. And in the denominator, we have 15 minus 0, which is 15. So now they want a decimal representation here. So I'm going to take negative in the bottom row of my TI-84 calculator, 27 division 15, and I get negative 1.8. Any questions on that?
No, I got that one.
That's great.
Yeah.
And so we just want to do that same process for part B. I don't think that's really any more difficult than part A. So let's just take our time and do this, and it shouldn't take too long. So we still want to do Y2 minus Y1 over X2 minus X1. So for part B, Y2 is 22.5, plug it in, minus Y1, which is 130.5, plug it in, divided by X2, which is 75, go ahead, plug it in, minus X1, which is 30, plug it in. And then just do the calculation and end up with negative 2.4. So that's good. I'm glad. And if you have any questions, please don't hesitate to ask. I don't want some little thing to hold you back.
Okay,
let's go. Well, look at the next one here. So now we are talking about writing equations of lines parallel and perpendicular to a given line. And really the toughest part of this is to identify the slope of the line that you're wanting to find. So it's nice that they say consider the line y equals 2/5 x plus 5, because it's already in slope-intercept form. So we can identify the slope of this line very quickly. The slope of this line that we're talking about is just the coefficient, the number in front of x, which is 2/5. So the slope of our given line is 2/5. Parallel lines have the same slope. So parallel lines have the same slope because slope is just a measure of steepness. And if here's a line and here's a line parallel to that. So let's take a look at those two. Imagine they're parallel. They didn't do a perfect job there, but it's at least the software works pretty well. So these two lines are parallel. They never intersect. They have the same steepness. If you imagine that they were a mountain grade and you were going to walk up each one of them, they would have the same stress on our legs. So they're really, since they are parallel, they have the same steepness. And since slope represents the steepness, think of slope as a measure of steepness. These are the same steepness, so therefore they have the same slope. So parallel lines have the same slope. And I think I have students trying to get in here. So let me just quickly come back to Teams for a moment and let in this person here. Some people are getting in automatically and some people are coming in as guests. And I think it's the people that are coming in as guests that I need to let in. That's where downloading Teams to your desktop comes in. You will be able to I will not need to come and let you in. So I will go back down to my desktop here. So parallel lines have the same steepness and therefore the same slope. So if I want to find the equation of a parallel line to our given line, this slope is 2/5. The slope of any parallel line is also going to be 2/5. The way we find the equation of a perpendicular line is it's a two-step process. We take the slope of the given line, which is 2/5, and we change the sign on that. So this is a positive 2/5. Change the sign on that to get a negative 2/5. And then once we have the negative 2/5, we just flip it over, turn it over, and get negative 5/2. We flip it over to get negative 5/2. So if you have any questions on how I got negative 5/2, I kept the negative sign. I took this 2/5, put the 2 in the denominator instead, put the 5 in the numerator. So let's look at finding the equation of a perpendicular line. Because Alex wants it first here, they're going to change the order on you, as you probably know. So let's do the perpendicular line first. We know the slope is negative 5/5, and then we just need a point on our line to use point slope form. So let's find a point on our line to do that. And we'll call that x1, y1. So we're told up here, find the equation of the line that is perpendicular to this line and passes through the point -4, 3. So down here, I copied down that point that the line passes through that we're trying to find, which is -4, 3. I labeled that as x1, y1. We know that our slope, which is m, equals -5/2. So it's just a matter of plugging in at this point. So here's our point slope form of the equation of a line. You're also welcome to use slope intercept form if you know how to use it for such a problem. So point slope form is y minus y1 equals the slope times x minus x1. So y minus y1 is 3 equals our slope, which is -5/2, times x minus x1. X minus x1 is -4. So now we're just going to clean this up. And right here, I just copied this over this entire side. Negative 5/2 I copied over. X copied over. Minus a minus is a plus 4. So we want to clean this up, and we want to state all the equations for lines in slope-intercept form, which means we need to solve for y. So the first thing I'm going to do is copy this over, y minus 3, and this is multiplication over addition, so we want to distribute. Negative 5/2 times x is negative 5/2 x. Right there. And then negative 5/2 times 4, negative 5 times 4 is negative 20. Oh, I just wrote it down like this, I see. So negative 5/2 times 4, right here, negative 5/2 times 4. So we now need to clean this up a bit. We copy this over, this over, this over, and what happened here is we have minus copied over. 5 times 4 is 20 divided by 2 is 10. And we want to solve for y. So the only thing we have to do is move this minus 3, the opposite of subtraction, addition, add 3 to both sides. And we get y on this side because these cancel. Negative 5/2 x copied down here. Negative 10 plus 3 is negative 7. Now, I mentioned quick checks a little earlier. I would recommend that in problems when you can, have a quick check just to make sure you get a warm and fuzzy that you've got the problem correctly. So over here, this x1, y1, we can use as x and y down here to check. So let's go ahead and do that real quickly. It'll save you time, and then you'll know that you've got the problem right. And I'm going to put in negative 4 for x here. I'll put it down below here. And then I'm putting in 3 for y here. And I'm going to close this off and look at that. So what I want to do is check this side and make sure this entire side, when we plug in the x and y coordinates, gives me 3. So let's look at this term right here. It's negative 5/2 times negative 4. Well, first of all, that's positive. Negative times negative is positive. 5 times this 4 is 20 divided by 2. 20 divided by 2 is 10. So all of this is equal to 10 minus 7, which is 3. So that point satisfies our equation. So I'm pretty confident I got that question right. The only thing that might be wrong is the slope is incorrect. So be sure you know how to take and find the slope of a perpendicular line. You take the slope of the given line, change the sign. So if it's positive, you change it to negative. If it's negative, you change it to positive. And then you take that number and just flip it over to get the slope of the perpendicular line. Any questions on this particular problem? At least part A.
No.
Thank you for your feedback. And at any point, any of you can jump in and ask questions. So let's look at the second part of this problem, which is to find the parallel line. So we're still wanting a line that goes through the same point, negative 4, 3, and the slope of a parallel line is 2/5. The slope of our given line, slope is that coefficient, the number multiplier in front of x, which is 2/5. Parallel lines have the same steepness. Since slope is a measure of steepness, they therefore have the same slope. So it's easy to find the slope of a parallel line. In this case, it's 2/5. And then we just go through the process again, but this time with the slope of 2/5. So we're plugging in for y1, we're plugging in 3. equals the slope, which is 2/5. So that's what we're plugging in here. So far we have y minus y1, which is 3, equals the slope, which is 2/5, x minus x1, which is -4. The only thing I copied this over. The only thing did on this side is a minus is a plus. So I changed that to a +4 here. And then what I did is I copied this over and this is multiplication over addition. So I distributed through the 2/5. 2/5 times x is right here. 2 times 4 is 8 over 5, right there. Solve for y. So we want to add 3 to both sides to get y by itself. And now what do we get? So this is very important. We get y on this side equals 2/5 x copied down. How do we combine these? Well, one way you can combine those is on your TI graphing calculator, which was stated in the syllabus as required for this course. So you can take 8/5, 8 divided by 5. So 8 division symbol 5, 8 division key 5, think of it that way, plus sign 3. And then all you want to do is go to the math key. It's in the very first column, 4th button down. Hit that button. And then all you do after that is hit the enter button, which is in the lower right corner of the calculator. Hit the enter button twice. And I got 23/5. Any questions on how to use a calculator to help you out there? And of course, we could check this by going back, plugging in this point. Nice quick check, -4, 3. So let's do that, -4, 3. So for x, we want to put in -4. Right here. And our y that we have is 3. So we want a nice quick check there too. Make sure we didn't make a silly error. So I'm going to do this one. So ever how you want to do this one, you can now know how to use the calculator to help you out if you didn't already. So what do I get here? This is going to be, this 2/5 is positive, this -4 is negative, so we're going to get a negative. So we're going to get a negative there. So 2 times 4 is 8/5. So we're going to get a -8/5 there. So what do I have here? Get my blue pencil there. I have -8/5 for this term. So -8/5. It's a little off there, I apologize. -8/5 there, plus 23/5. So what you could do, you could take just 23 minus 8, since both this -8/5 has a denominator of 5 and this 23/5 has a denominator of 5. You can take, since we have like denominators, we can just work with the numerators. Negative in the bottom row of the calculator, it's that little negative in parentheses. So we've got -8 and then plus 23. That gives us 15 up here. When we combine, well, actually -8 plus 23, -8 plus 23. With this -8 plus 23 gives us 15 divided by 5, which is 3. So I know that I've likely gotten this problem correct. Any questions on this topic, on parallel and perpendicular lines? Please feel free to ask questions. That's what I'm here for. I want you all to feel free to ask questions. I want you to get your questions answered. So if anybody have any questions about this problem? It's got a part A and a B.
Mm-mm. Nope.
Good. But if you have a question, that's also good. So let's go to the next topic. So as I mentioned earlier, these 7 written work topics will be the first 7 questions on your test. That way it'll make it easy for you to know which ones you need to upload to Canvas. So this is about writing an equation and drawing its graph to model a real world situation. And I think we can all relate to having to buy gas. So Caitlin is driving on the highway. She begins the trip with 12 gallons of gas in her car. The car uses up 1 gallon of gas every 20 miles. So let G represent the number of gallons of gas she has left in her tank. Has left in her tank is very important. It's not how much has she used, it's how much she has left in her tank. And let D represent the total distance in miles she has traveled. Write an equation relating G to D and then graph your equation using the axes below. Now, one of what I want to caution you to really watch out for, we're so used to working X and Y, and Alex won't accept X and Y for this problem. You've got to, please be sure you remember to use D and G. Use D and G instead. You can work X and Y through the problem, but when you are typing in your answers, make sure you convert back to D and G. So what we want to do, and you can assume that we're going to get a linear graph here, you need 2 points to determine a line. So the first point we want to use, I'm not sure why I'm getting those notifications, and I wish I knew how to turn them off because they don't. I don't know if my daughters are coming over from her computer. She's probably she's in high school and she has a lot of homework. So I don't know what's going on there. I'm going to have to investigate. Sorry about that. So we want 2 points on our line. We want to figure out the coordinates of those 2 points. So I would recommend that you always try 0. It's easy to work with. So if she's still in her garage, or how much gasoline does she have left in her tank? How many gallons does she have left in her tank if she's still in the garage and hasn't used any gas? She's got all of it left, 12 gallons. So our first ordered pair is 0, 12. Now, this statement here, the car uses up 1 gallon of gas every 20 miles. So what do I want to do? I want to take advantage of that. What's on this axis here, the y-axis, is the number of gallons left in her tank. So she uses up 1 gallon every 20 miles. So what is D? D is distance. So let's use a D. Let's use it to be, let's put in 20 for D because we know what's going on every 20 miles here. And there's many variants of this problem. We know what's going on every 20 miles here. So I put in 20 and distance is on the, what we think of as the x-axis. So I put in 20 first. So now every 20 miles, she uses up 1 gallon of gas. So she's at the 20-mile mark right now. That how many gallons does she have left? She uses up 1 gallon. She started with 12, minus 1 is 11. So this is what we have right here. We have 2 ordered pairs. We can then find the slope. I think every one of these variants of this particular topic, I've been teaching Alex for 3 years. I think I've always seen that you could use 0. So that's really good to use that. So we just labeled this one x1, y1, x2, y2. Find the slope. No matter what way you find the equations of your lines, you want to always find the slope. So y2 minus y1 over x2 minus x1, I've got them labeled here. Y2 is 11 minus y1, 12, divided by x2, 20, minus x1, 0. So this is 11 minus 12, which is negative 1. This is 20 minus 0, which is 20. So we have the slope of our line. Notice over here, this point, 0, 12, and this is why it's so important to use that. That's on that 0, 12 is on the what we think of as the y-axis. That 12 is our B. That 12 is the y-coordinate of the y-axis, which is what we call B when we're talking about lines. So we don't have to plug in very much. We can use y equals mx plus b form here to write the equation of our line. All we're going to do is plug in our slope, which is negative 1/20th. I plug that in for b, negative 1/20th, to get negative 1/20th times x plus our b, which is 12. Now, the only problem with typing in this answer is Alex doesn't want that because it's not the variables. X and Y are not the variables that we were given. It's just easier to work X and Y, I think, because we're so used to it. So we have to figure out which variables to use. So D is on the y-axis here. So I took out the X, put in capital D. D is on the x-axis. I want to make sure I'm clear. D is on the x-axis. So I took out X, plugged in D. G, on the other hand, is the y-axis, is on the y-axis. G is the y, right up here. So you want to make sure you're keeping track of that ever how you want to. So we want to take out Y and replace it by G. So we're going to take out Y here and replace it by G to get our answer. And you can quick check this too. How do you quick check this? Put in 0 for D. If I put in 0 for D, what do I get out? I get G is 12, which is what it is. You could also quick check it with this ordered pair as well. So those quick checks are really nice. Any questions on this particular topic?
Mm-mm.
Good. And feel free to ask questions by unmuting your mic and just speaking into your mic. That's what I'm here for. So let's take a look at this particular topic, finding the difference quotient for a linear or quadratic function. If you go on to Survey of Calculus or Calc 1, you will definitely see this. So it's important, and it also will deepen your understanding of functions. So we want to find the difference quotient f of x plus h minus f of x over h. So it's called the difference quotient because we have a difference going on in the numerator with that subtraction. And then because of the division here, it's a quotient. Of course, we can't divide by 0. We cannot have our entire denominator equal to 0. You could put in your favorite number and divide by 0 on your calculator. and you will get an error. Attempted calculation contains division by 0. Calculation fails. So they took h and said it can't be equal to 0. So what do we want to do? We want to find this, the difference quotient for this function. Now this x here in this function, this x inside the parentheses here really means the word input. We as mathematicians don't like to write out the word input all the time, but sometimes it really does help. So everywhere there is an x here, I took it out and wrote in input to help us out. So we're going to take advantage of that. So the first thing I want to do here is we want to break this job down and we want to find f of x plus h. Now here, this input, what's in parentheses is our input. So our input is x plus h here. It's x plus a little bit more. That h actually stands for an infinitesimal bit more in calculus. So that's what this is. This input is x plus h. When we find f of x plus h here, I'm going to do what? I'm going to use this input and I'm going to use this function right there. So everywhere I see an x, I want to make sure to write down x plus h because that's what's in the parentheses here and therefore what goes in the parentheses there. And then that means we have to put x plus h here for this x and here. So let's do that. So we get f of x plus h equals this -2 copied down. This x is really, oh, you can look over here as well. So we're going to write that. Let's do that. So actually what we're writing down is -2 times our input. Our input here is x plus h. And then we're going to square that right here. So we put the square here. Plus 6 times our input. We write down the plus 6 and our input is what's inside the parentheses, which is x plus h. Minus this 3. So before we go on, we want to do all we can with f of x plus h. This right here means this exponent here, this power here means we take 2 of this base x plus h and multiply them together. This is a binomial squared. So we take 2 of this base x plus h and multiply them together. That's x plus h times x plus h. An exponent is just a mathematician's way of quickly stating we want repeated multiplication. So we now want to multiply these together. So this is 2 terms times 2 terms, so we can FOIL. The first 2 is x times x, which is x squared. The outer 2, xh. The inner 2, hx, but multiplication is commutative, so we can write that as xh. So we have an xh from here, another one from here. We actually have 2xh. Plus h times h, which is h squared. So we're going to take this out and replace it by x squared plus 2xh plus h squared inside here. Now what we can do, this is multiplication over addition. This is multiplication over addition. And by the way, subtraction's adding a negative, so it's over addition or subtraction really. And we just want to work, we want to distribute in this step. So I only like to do one process per step. So we're going to distribute this -2 through, get -2x squared. -2 times 2 is -4 of what? xh. -2 times 1 here, I understood 1 is -2 times h squared plus, now to distribute this 6 through to get 6x plus 6h, copy over the -3. There's no like terms here at all. Like terms have not only the same variable, but also to the same exponent. Like terms have the same variables to the same exponents, and we don't have any of that. So at this stage, we're done with finding this f of x plus h here. So now let's subtract off this f of x. So we've got f of x plus h minus f of x now that we want to find. Well, we know what f of x plus h is. We just found it. So I just copied that all over here. Minus here, f of x, and we want to make sure we're putting f of x in parentheses because it has more than one term. F of x, that has stated right here. Luckily, we've got it stated for us. That's minus 2x squared plus 6x minus 3. So I put that in parentheses, minus 2x squared plus 6x minus 3. And then we're going to cancel. So really what we have here is minus a -3, which is a +3. And I see a -3 here. So those are going to cancel. So I canceled this with that 3, that -3 here. So we have -3 minus a minus plus 3, which is 0. It's not contributing. Then we have minus 6x. We've got a plus 6x here. That's going to sum to 0. So we cancel those. Then we have a minus times a minus, which is a plus 2x squared. We've got a minus 2x squared over here. So those cancel because we get 0. And 0 plus what's left is what's left. What you notice now is every term that's left, this term, this term, this term, has an h in it. So I want to remark for your written work, when you're crossing out these numbers, make sure I can see the numbers and expressions, the variables underneath. So you might want to write dark and cross out lightly. So what's left here? Every one of these terms has an h in it. Let's factor that one of those h's out front because each term has only one h in it. So I'm going to factor the h out front. What's left goes in parentheses. This h went out front, so -4x is left. One of these h's goes out front, so one of them's left, so we get minus 2h here. And then over here, we're taking this h out all the way out front, so the +6 is left. So that's all we can do with the difference part of the difference quotient. So the only other step we need to do is to divide by this h here. So we're going to take, and first of all, I want to label and make, so you understand that we are now finding f of x plus h minus f of x over h. So we've got f of x plus h minus f of x, which is what we just found up here. Just copy that over right here. And then just divide by h. Well, h divided by h is 1 times what's left is what's left. And that is -4x minus 2h plus 6. So that is our difference quotient, which goes up in the box right here in Alex. Any questions about this particular topic? That's probably the most labor-intensive topic that you have. Now, you might say the parallel and perpendicular line problem because there were 2 parts, that one too. So any questions on finding the difference quotient? You're likely to get a quadratic one on the test. It may or may not have the middle term here. So with these problems, I really encourage you to do a few of each one of these prior to the test, writing out your written work, just so you can see the different variants of the problem. So let's go to this next topic here. Quotient of two functions, basic. So we are combining functions here. Now, the issue with a quotient is we need to stay away from division by zero, because if your entire denominator is zero, division by zero is undefined. So that's the issue here. So we've got, this is a two-parter. We have part A and B. H of x equals x minus 8. G of x equals parenthesis x minus 5 parenthesis x plus 3 parenthesis. So we've got two functions floating around. Part A, find h divided by g at an x coordinate of -2. So let's go down here and do part A first. We were given the problem as h divided by g, parenthesis, -2 parenthesis. Let's turn this into what I would call workable form. Really what we're finding, this is just shorthand, really what we want to find is h of -2 in the numerator divided by g of -2 in the denominator. This form I feel is more workable. We call it workable form. This is shorthand. We have a lot of shorthand in math. So what we want to do here is to find the y coordinate of the h function when x is -2. So we want to go up to our h function and plug in -2 for x. And we get -2 minus 8, which is what we see here. G of -2 means we want the y coordinate of our g function at x equals -2. Our g function's right here, so we want to plug -2 in for this, that x, and this one too. So we get -2 minus 5 right here times -2 plus 3 right there. And we just need to clean that up. -2 minus 8, -10 in the numerator. -2 minus 5, -7. Times -2 plus 3 is 1. First of all, negative over negative, two negatives make a positive. This is positive, 10 over 7. I always like to find my signs first so that I don't forget. So part A, the answer is 10 over 7. Any questions on part A? Thank you. I love all the, feel free to ask questions. That's what I'm here for. I want to make sure you all, nothing small or large holds you back. Let's look at part B. Find all values that are not in the domain of h divided by g. Remember, domain is a set of all x's for which the function makes sense. If there are x's that cause division by 0, that is not going to, our function's not going to make sense because division by 0 is undefined. So we need to figure out what's the x's which are going to cause division by 0 and then throw those out. And actually, Alex just wants in part B, values that are not in the domain of h divided by g. So we just have to figure out what those two values are in this case. So what do? Well, first of all, we are asked to find values that are not in the domain of h over g. I'm going to write this, let's rewrite this. H over g means h of x over g of x. We can't have division by 0. So we're only concerned about our denominator. We're not asked to evaluate this function. We are only asked to find the values that are not in the domain. And those are going to be the x's which cause division by 0. And that will make the entire function undefined. So since we can have division by 0, what's in the denominator? The denominator is g of x. What is g of x? It is x minus 5 times x plus 3. So I wrote down x minus 5 times x plus 3, set it equal to 0 because our whole entire denominator can't be 0. So we are setting it equal to 0 to find the numbers to throw out. So this is a product. This is x minus 5 times x plus 3 equals 0. So we know how to find those numbers pretty quickly. This represents a number, this represents a number, and the only way to have two numbers multiplied together to give 0 is if one of them is 0. So this is 0 when what? X equals the opposite sign. X equals 5 on this side, if you want to look at it that way. Or you could just say, okay, x minus 5 equals 0. I've got to move this minus 5 to the other side, and that means I have to add 5 to both sides. So I'm going to get x equals 5. Over here, let's set this factor equal to 0. This is x plus 3. That would mean we'd get x plus 3 equals 0. We subtract 3 from both sides, and we would get x equals negative 3. Can't have these values. These are the two values, 5 and negative 3, that Alex was looking for right here. Any questions on this particular topic? It's very important if you're going on in math to realize that you can't have division by 0. It creates all kinds of problems. So let's go on. I think we only have one more left. And feel free to ask questions. We can back up, whatever. So on this one in particular, we're given a cube root function and asked to find the inverse of it. Some of the variants in this for this particular topic, you'll be given a cubic and asked to find the inverse of it. So some of you might get the cube root function at the start. Some of this, you might get the cubic at the start. So it's important to practice at least one of each of those. So we have a one-to-one function, which means we have for each x, we have only one y, and for each y, we have only one x. Here's our function. We want to go through this process of finding the inverse of this function. So the process I wrote down here. We replace our original function notation by y. Yeah, it really is the y, but this is just helpful because it's the y coordinate of the f function with respect to x, especially if we have multiple functions lying around. So that's what we do first. We replace f of x by y. And then what's really important when we're talking about the inverse of a function is that we switch the x and the y. So we're going to take the y and replace it by x, and also take the x and replace it by y, and then solve for y. And then we want to replace the new y by the f inverse of x notation. F inverse of x notation just represents, we have f to tell us that this is the inverse. That's not -1 really. It represents inverse, the word inverse. And it tells us the inverse of which function? The f function. So if you got multiple functions lying around, it's important to label it correctly. So let's go through this process. We're going to first copy our function down that we're given. That's what I did here. Now we're going to take out your f of x, d of x, h of x, whatever it is, and replace it by y. So I took this out, replaced it by y, just copied everything over on this side. So next step, this step, replace y by x. So here's our y, replace it by x. Replace x by y. Here's our x. We're going to take that out, replace it by y to find the inverse. And we're going to copy over -9 and this +4. Last step, solve for y. So let's move this +4 to the other side, the opposite of adding, subtracting. Subtract 4 from both sides. On this side, we get x -4. Copy over this. +4 -4 is 0. +0 isn't contributing anything to this problem, so we don't write it in. And now we want to continue to solve for y. So we've isolated this cube root. So this 3 we write in the v. That's what's called the index. We don't write it in for a square root because we use them so much. We just know that index is a 2. So when you're working a problem like this, think of what the opposite of square rooting is. It's squaring. So the opposite of cube rooting is cubing. So we want to cube both sides. So we want to put each side in parentheses and cube it. And that's what I did here. Cubing undoes cube rooting. So all we're left with on this side is this, what's inside the radical here, which is y -9. And I just copied over this side. So to solve for y, all we have to do is move this -9 to the other side. So we're going to add 9 to both sides. And we get, on this side, we get x -4 cubed plus 9 equals, these cancel, y on this side. And the last step is to replace that y by the f inverse notation of, and make sure we've got our x here. So we have f inverse of x equals this copied over right there. Any questions on that? And then I also copied that up here, at least the right side of it. And actually that's all Alex wanted because they have the f inverse of x right here. They wanted the right side. So let me come up to you all. I wanted to present the written work. Required topics, that's worth 49 points on your test. And I'm wondering if you have any questions on what I presented. I did record this, and sometime tomorrow morning I will I will send you all a Canvas email with the link to the recording in it, so you can go back and revisit that recording if you wish. So does anybody have any questions on what I just went over, or any other questions in Alex for that matter, or any questions about the test or how to study for the test and so forth? Anybody have any questions? And if you're in doubt, please ask questions. Anybody have any questions? You all good?
Mm-hmm.
Okay, that's great. Jonathan and Matali, are you good? Thanks for coming. I really appreciate it. If you need any help, please reach out to me. I'm only an email away, so I would check my email pretty often. And I'm so glad you attended, and it's nice to see some students in my online class attend a Microsoft Teams meeting. If you would like, I'm a little bit behind, this class, but I have 2 remote classes, in which we're covering the same topic. So that's an option if you would like. You are by no means required to do that. So take care unless you have any questions. Stay safe and all of that. And I wish you good luck on the test. I hope the test goes really well for you. So take care, and I hope to see you at a future test review conference. We'll have one for test 3 and one for the comprehensive final as well. Take care. Bye for now. You're welcome to stick around if you've got individual questions. I'll stay online until you've all left the conference or we continue if you have a question. Bye for now. Take care. Feel free to leave. Vitaly, how's it going? Is it going well for you?
Oh, yes, I'm trying.
Do you have any questions?
Not right now. The question you answered the questions that I was having trouble with.
And you really understand it?
Yes, the steps you made helped a lot.
Oh,
I'm here doing the review.
that's good. And also, I put my notes in from today. I put them in the Alex course. If you go to instructor resources, you should be able to see them. So if you click on those 3 horizontal bars in the top upper left of the screen, then you'll get the main menu in Alex. And if you go down, you'll see instructor resources. Does that make sense?
For this test?
You'll see yes, this should be for this particular, what I just presented today, right?
Okay. Thank
Okay.
you. I'm gonna go there right now.
Okay. Do you have any other questions? You good?
I don't have any. Yes, I'm good right now. Can I email you if I have any questions?
Absolutely. Yes. Yes, yes, yes.
Okay, thank you. Thank you very much. My background is kind of noisy.
Oh, see you later. Take care. Hope your whole family takes care. Goodbye for now.
Thank you. You too.
You're wasting.